So I'm actually re-recording this podcast because the wind was so strong that the noise was too much. So this is part of the climate change adaptation I have made and the price I have to pay in terms of living without air conditioning in Mumbai. Very nice breeze, but it really spoils the sound on the recording. Anyways, so we looked at the demand side solutions for mitigating climate change and some of the issues and sector-based approaches. We'll add some details about the framework for such a assessment of demand side solutions, and then in the next podcast we'll look at the details on how much potential there is for reducing greenhouse gases. So this paper looks at key research questions and contributing disciplines for assessing demand side solutions to mitigate climate change. Technology, end-use context and well-being have to be kept in mind to drive policy instruments. So policy instruments also have to meet technology demands for demand-side solutions, and well-being also has to be kept in mind, because anything that helps climate change but helps mitigate climate change but doesn't improve well-being or significantly worsens it will not be acceptable. So the wind is greatly reduced, but there's still some breeze because the screen is open. I mean, I have a screen, so some wind still gets through, which is what makes it possible to live without AC, but so it goes. Okay, together they have to add up to climate mitigation pathways, and we have to always keep in mind sustainable development goals, because again, sustainable development goals offer independent mapping for making sure that we are reducing poverty, climate justice, equity, gender equity, and access to water, education, energy, etc. are being met. So under technology, what are the greenhouse gas emissions, costs and potentials associated with a given technology or system of provision? So here the disciplines involved are engineering, industrial ecology, technological innovation studies. They should map onto end-use context where we have to worry about norms, values, preferences and structural factors that shape energy demand and greenhouse gas emissions, with disciplines being involved are economics, marketing studies, psychology, sociology, transition studies and urban studies. And they should worry about well-being. How do demand-side mitigation measures impact on human well-being, which can be studied in terms of economics, philosophy and psychology. Some wind there, sorry. Policy instruments then should address which measures under what conditions can reduce demand-side greenhouse gas emissions. How can measures best be implemented and become part of everyday practice? So this would include economics, political sciences, psychology, sociology, transition studies, and urban studies. The climate mitigation pathways. How does the demand side contribute to limiting global warming? How do demand solutions interact with supply sectors? Integrated assessment modeling is needed here, and partial equilibrium models, which I won't go into, but obviously you can think of also transient solutions as we are heading towards net zero and global warming targets. Integrated assessment models we have talked about elsewhere, which are models that include socioeconomics like sectors, transportation, energy, food, health, etc., and transitions, and climate being a driver rather than like the Earth system models where climate is the main thing we are modeling, right? It's the main system we are modeling. Sustainable development. What are the synergies and trade-offs between demand-side solutions and sustainable development? We need here development studies, geography, and political sciences again. So the Avoid, Shift, Improve framework approach originated in the early 1990s in Germany to structure policy measures that reduce the environmental impacts of transports. It was then taken up by international non-governmental organizations to address rapid motorization in developing countries in the 2000s, and was endorsed by Asian and Latin American countries in 2013 Bogota Declaration on Sustainable Transport. Bogota, Colombia is a model city for how one mayor made a massive difference in the way to design urban transportation, green spaces, places for people to walk, ride bicycles, improve health and overall well-being and so on. And I think the model has been copied into other cities across South America as well. And of course, Denmark and Sweden and Netherlands offer similar approaches. According to this approach, policies to limit greenhouse gas emissions in the transport sector need to consist of measures aimed at avoiding the need to travel, for example by improved urban planning or teleworking, shifting travel to the lowest carbon mode such as cycling, and improving vehicles to more energy efficient and fuels to be less carbon intensive. Sounds easy, right? Illustrative avoid shift improve options in different sectors and services. We will look at more specific examples and avoided emissions, potentially avoidable emissions by 2050 in the next podcast. So the sectors are transport, buildings, manufactured products and services, and food. The services they provide include accessibility, mobility, shelter, clothing and appliances, and nutrition. Under avoid, you would have things like integrate transport and land use planning, smart logistics, teleworking, and compact cities. For buildings, you will avoid passive house or retrofit, avoiding demand for heating and cooling, and change temperature set points. Setting air conditioners at 22 degrees centigrade instead of 18 degrees centigrade can save a lot of energy, for example. Long-lasting fabric, appliances, sharing economy, industrial parks, circular economy. So circular economy is a concept that's still not fully functional. Hopefully it doesn't become like ecosystem services and ecosystem based approaches to managing ecosystems and so on will be more real in terms of reusing and recycling and reducing use, consumption, etc. Calories in line with daily needs, food waste reduction. We talked about food waste being 6% of the total emissions, which is absolutely no regret decision in terms of reducing food waste to reduce emissions. Even countries like India and China waste a lot as people get richer, middle class grows. Okay. So more shift from car to cycling, walking, or public transit. This of course depends on the behavioral changes and how they can be incentivized, and Bogota, Colombia and Denmark are examples. One is a developing country, one is a rich country. Under buildings you have heat pumps, district heating and cooling, combined heat and power, inverter air conditioning. These are becoming much more common in the UK and even in some parts of US, for example. Shift to recycled materials, low carbon materials for buildings and infrastructure. We have talked about reducing emissions from cement and steel, for example. Shift from ruminant meat to other protein sources where appropriate. So here endogenous cultural rational choices and peer pressure, etc., can be considered to see how to bring about behavioral changes in terms of reducing ruminant meat consumption, for example. In terms of improvements in these sectors, electric 2, 3 and 4 wheelers, eco-driving, electric vehicles, smaller light weight vehicles. For buildings we can have condensing boilers, incremental insulation options, energy efficient appliances, which is a serious contributor to reducing emissions, but of course we have to move towards not using fossil fuels efficiently, but just moving away from fossil fuels and leaving them in the ground, which is a separate issue. For manufactured products and services, use of low carbon fabric, new manufacturing processes and equipment use. And under nutrition, food, reuse food waste, smaller efficient fridges, healthy fresh food to replace processed food, which also has a huge co-benefit in terms of health, reducing inflammation and so on and so forth. The next paper looked at thousands of papers which have been studying supply side, demand side solutions explicitly stated, and the analysis was done to look for cluster oriented summary of key messages from these highly relevant and highly cited academic publications of each topic model. So the clusters were policy, housing, mobility, and consumption. So I won't read this whole table, but I will just read examples. So let's start with the housing cluster. Buildings' greenhouse gas emissions can be reduced by retrofitting with passive design, efficient technologies and controls, and distributed renewables. Under housing, governance operates on multiple scales and includes many actors, all of relevance for climate change mitigation. Okay, for countries like India, rural households are often vulnerable and require information and credit to adapt to climate change. So we have talked about adaptation elsewhere, and incentivizing adaptation and avoiding maladaptation become critical as well in thinking about demand side solutions. Finally here, another example, communities can instigate local energy and retrofitting projects and create trust, but operate in the context of broader governance. So these include all these disciplines that we talked about. Climate change, global warming is local, and it's not so much a natural science problem as it is socioeconomic, social science, governance, political science problem, and financial problem. Under policy cluster, sustainability encompasses holistic goal thinking, drawing bridges between social and physical sciences. This barrier has to be bridged even in the research institutions, academia, in terms of the reward system for pursuing solutions rather than just publications, for example. With international trade, not only territorial but also consumption-based greenhouse gas emission footprints require policy attention. In other words, China may be manufacturing a lot of things and having high emission, but if those products that are then shipped elsewhere and consumed elsewhere, then accounting has to be done appropriately to assign blame for emissions, also at the consumption side, accounting for embedded carbon, which we have talked about elsewhere. Another example under policy cluster, cost savings motivate reducing energy and material use, but current cost-benefit analysis undervalues uncertain environmental damages. So the idea of putting values on non-market goods like ecosystem services or environmental damages due to human activities need a special care as well. Moving on to mobility cluster, connected mixed-use and medium-density cities with public transport systems and cycling infrastructure avoid the necessity of car use. This is going to be a massive retrofit for urban centers in India, for example. All the cities have become impossible in terms of riding a bicycle. Even two-wheelers are deadly dangerous. Too many accidents per day in big cities for people traveling on two-wheelers. Okay. Another example, attitudes, perceived behavioral control, and charging station unavailability are key constraints for adoption of electric vehicles. So one has to worry about mobility clusters. In India, number of electric vehicles is growing impressively, but if the energy source doesn't become clean very soon, then the old grid will not necessarily reduce pollution, it'll just shift it from traffic centers, which can still be good if pollution from energy production is away from population centers, but often that's not the case. So one has to be very careful about mobility being clean but the recharging power being dirty. Okay. Under consumption cluster, farm system solutions reducing food mileage and especially dietary shift can reduce greenhouse gas emissions dramatically and improve health. But just because something is good for us doesn't mean we will do it. So how to accomplish dietary shifts is not very clear. That's where the incentivizing and liberalism and how people think about their role in helping the environment and society come in. And we will look at some of this in the next podcast in terms of endogenous and exogenous demands on the supply side and demand side, and how to evaluate them in solutions. Okay. High growth in tourism and aviation endangers climate stabilization, with COVID-19 opening the opportunity to rethink tourism. Well, this was spoken too early because COVID-19 is almost on its way out, let's hope. And a lot of the economies that suffered because of the lockdown have started stimulus funds for reviving economies, but those additional funds made available are not necessarily aimed at green technology, green transportation, and so on. So emissions are way back up already again. So the dip that happened because of the COVID-19 lockdowns and slowdown of transportation, manufacturing, etc., have almost completely rebounded now. So we may have spoken too soon. Plus, the Russian invasion of Ukraine only has added to this mess. So sustaining climate action and demand-side solutions under such stressors, external stressors like pandemics and wars, is not an easy task, but we must somehow accomplish it. Another example, reducing waste and reusing it for new purposes are central tenets of a still speculative circular economy. So hopefully circular economy will become a reality, and it will become a big part of the demand side solution to mitigate climate change. Okay, so we'll come back and look at the specific ideas under ASI, avoid, shift and improve in each sector, and look at estimates of how much emissions reduction they can contribute to by 2050, and we will see what specific measures are possible in each sector. Okay, that's in the next podcast. So I will check to see how bad the wind rustling is in this podcast. Hopefully not too bad, and then at least remember that it reminds you of the adaptation I'm making in terms of living without air conditioning in April, in all months in Mumbai, which is very hot. So let me leave it here.